Okay, so this section we will continue to talk about dividing the polynomials. So there are two methods for dividing the polynomials, long division and synthetic division. I believe that you guys are pretty familiar with synthetic division here. And so first we will introduce long division here. So how could we do long division of polynomials when you have two polynomials? Yeah, so like this, divide each other. So what are the steps? So the first step is arrange the terms in decreasing order with a zero coefficient for any missing term. This means, okay, so we have to rearrange these terms so that the power exponent is in descending order. So perfect here, perfect here. Do we have any missing term? Means, for example, if you have x cubed plus x plus 1. So what do we miss here? So you have x cubed plus what? 0x squared plus x plus 1. Okay, so this is an example for missing term. Okay, and then step 2, we wanted to divide the leading term in the dividend by the leading term in the divisor. So what is the leading term in the dividend? X squared. The leading term in the divisor, x. So your step 2, so it will be x squared divided by x. What do we have here? It's x. X is where you put as what? On the quotient here. Okay, so then the step 3. Okay, step 3, multiply every term of the divisor by the first term of the quotient. So multiply every term of the divisor x plus 2 times what? X. So what do we have here? Distribute x squared plus what? 2x. The step 4. So step 4, subtract the product from the dividend. So you subtract the product. From the dividend. So x squared plus 2x. Okay, so when you do the subtraction, what should we do? Yeah, so you have to what? Change the sign. Yeah, so here, yeah. And then what do you get? The first term cancel, 10 minus 2, what do you have? 8x. So here the hint is, so when you subtract, what happens? The first term or the leading term will always be cancelled. Okay, and one important thing is do not forget to change the sign. So then we will bring down the next term. Okay, and then bring down the next term. And then what will you do? Repeat all these 3 steps. Yeah, so what will you do again? Okay, so step 2. Okay, so 8x divided by x again. What do you have? Plus 8. And step 3. So x plus 2 times 8 again. What do you have? 8x plus 16. And step 4. It will be 8x plus 16. Then you would subtract. You change the sign. So what do you have? 5. So subtract. Okay, so what do we call here? And we call this is your quotient. This is your remainder. Okay, so how could we write? We write x squared plus 10x plus 21. We can use fractions for division. What does this equal to? It's x plus 8 and plus what? 5 over x plus 2. So your quotient is right here, and your remainder is right here. And on top of your remainder is your, on the denominator is your divisor. Okay, so this is the long division. Okay, so the next thing is for synthetic division. Synthetic division, so your divisor has to be in the form of what? X minus c. Okay, x minus c. Okay, so otherwise you cannot use synthetic division. But for long division, it is complicated, but your divisor can be anything. So long division is more powerful than synthetic division. Okay, so we will use the same thing here. You not the same thing. You follow all these steps. Yeah. So we have an example here: 5x cubed plus 8 plus 6x divided by x plus 2. What is the first step? Arrange the polynomial in descending order and write a 0 for the missing term. So 5x cubed. The next term is 6x. What do you miss here? The x squared term. So I put x squared term here, plus 6x plus 8. Okay, so x plus 2. Okay, so then we wanted to step to rewrite c for the divisor x what? Minus c. So if you have a plus here, it has to be the opposite sign. So plus 2, so what will be your c? Negative 2. Not positive because you have a minus there. And write the leading coefficient of the dividend on the bottom row. Okay, so we wanted to write down all the coefficient of the dividend. So what do we have? 5, 0, 6, and what? 8. Okay, and for the first coefficient, okay, so what will we do? We write it down. We always keep it. Okay, so this means write the leading coefficient. You keep the leading coefficient here, and then what will you do? You multiply these two numbers and put it here. So negative 2 times 5, what do you get here? And what will you do the next step? You add these two numbers here. You will what? Get negative 2, negative 10. Then what will you do? You repeat the same thing. So negative 2 times negative 20, what do you have? 20. You add this. So what do you have? 26. Add negative 52. And what do you have here? You have what? Negative 44. Okay, so your last thing is what? Called what? Your remainder. And this part is your quotient, the coefficient of your quotient. But what is the quotient here? Okay, so it will be what? So here is x cubed. So and then what will be the first term here? It's always what? 1 power down. Okay, 1 power down. So it will be what? 5x squared. So x cubed, it will be x. It's always 1 power down here. Then the next term will be what? X. The next term will be what? Constant. So the quotient is what? 5x squared minus 10x what? Plus what? 26. So what is our final answer here? 5x cubed plus 8 plus 6x divided by x plus 2 is 5x squared minus 10x plus 26 plus what? Negative 44 over x plus 2. Okay, so your quotient is always what? 1 power down for the sensitive division because it always divided by x minus c. Okay. Okay, so the next thing that we want to talk about is the remainder theorem. Okay, so the remainder theorem is about polynomial fx divided by x minus c. We can use what? Sensitive division. Then the remainder is always what? fc. The remainder is always what? fc. So what does this mean? If we wanted to find fc, we can always use sensitive division to find the remainder. That's the same thing. Okay? So if given a function like this, use the sensitive division and remainder theorem to find f of negative 4. So to find f of negative 4 means, what is negative 4? C is what? Negative 4. With me? Okay, so we can use sensitive division. What should we do? You put a C in the corner here. You write down all the coefficient. 5, negative 6, 5, 1. So you do not have any missing term here. So for the first one, you keep it, yeah? For first leading coefficient, you keep it. And then you multiply, you add, yeah? Repeat the process. You multiply, and then you what? Add here. You with me? And multiply and add. So you get the remainder is what? Negative 435. So f for negative 4 is what? Negative 435. Okay, and the quotient here is what? Because it's x cubed, you start with what? X squared. 5x squared minus 26x plus 109. Okay, so the leading power is the 1 less the leading power. Okay, so I need to of the quotient is 1 less than the power of the dividend. Okay, of the quotient. Okay, so the next theorem is called what? The factor theorem. So let f of x be a polynomial. If fc, so if fc equals 0, then x minus c is a factor. So fc equals 0, what does this mean? Remainder equal to 0, yeah? So if the remainder is 0, then x minus c is a factor. And if fx minus c is a factor, then what happened? The remainder is 0. Yeah, so fc is also the remainder is also 0. Okay, so we wanted to apply this. So solve the equation x cubed plus 2x squared minus 5 minus 6 equals 0, given that 2 is a 0 of this thing. Okay, so how could we use this? So 2 is a 0. Yeah, so if 2 is a 0, what does this mean? So if c, x minus 2 is a factor. Okay, so what means x minus 2 is a factor? If you look at the 2 is your c, and your remainder has to be what? 0. Perfect. Okay, so then we wanted to see what will be our quotient now. Okay, so we write all the coefficient here. What should we do with your leading coefficient? You keep it what? Here. And then what will you do? You multiply here. So you get what? 2. And then you add, you get 4. Same step. 8, 3, 6. Perfect. 0. Yeah. So what happens here? What is the quotient here? The first term is what? 1 less than the dividend. So it's what? X squared plus what? 4x what? Plus 3. So quotient is this. So whatever you have, fx, you have a factor x minus 2, yeah, times your quotient. Yeah, so because this is a factor, so what happened here? Okay, so if some student did, okay, so if some student do not understand here, so think about this. So what does this mean? This is a factor, means, okay, so x cubed plus 2x squared minus 5x minus 6. You divide, yeah, so it's a divisor, you divide x minus 2. What does this equal to? X squared plus 4x plus 3. That is your what? Quotient. Plus the remainder. What is the remainder? 0 over x minus 2. So what does this thing equal to? X squared plus 4x plus 3. You with me? Yeah. So this is the rationale. Yeah. Okay. So then what happened? You multiply x minus 2 on both sides. You will get this. Okay. So what do we wanted to do here? So you actually wanted what? Fx to be a factor. To be factoring like this. X minus 2, x squared plus 4x plus 3 equal to what? 0. Because why do you want to factor? Because we learned every part be equal to 0. So we will have what? X minus 2 equal to 0, or x squared plus 4x plus 3 equal to 0. So here x equal to 2, or what do we need to do here? You can factor again. 3, 1, so x plus 3, x plus 1 equal to 0. Then x plus 3 equal to 0, or x plus 1 equal to 0. So x equal to negative 3, or x equal to what? Negative 1. You with me? So you can find all the other two solutions. So if you know one solution, what could we do? We can use synthetic divisions to find the quotient. So this means to find the factor, to factor the fx. So write like a product of two factors, and then try to solve the remaining factor. Okay.